we are manipulating functions before differentiation. And basically what this means is usually there's several techniques that we can use to do a derivative on a function, but oftentimes if we manipulate it or change the way it looks, there might be an easier way to attack the function, to do the derivative on it. So let's go ahead and see what the question asks. How would we what? Rewrite h of x. So we need to rewrite h of x so it can be differentiated using the power rule. All right, so how would we rewrite this to use the power rule? Well, what's going on right here? We have these two x functions basically that are multiplying each other. So this would be a product rule in its current state, but they want us to use the power rule. The power rule would be if there was no multiplication going on here between the x's. Notice x times x right here. So the trick would be just to multiply it out first, and then we can apply the power rule. All right, so let's just go ahead and do that. It looks like going through these answers, it would be this one right here, but let's check. Be careful, this would be still we have an x times x here. This is an x divided by x, so I don't even know if these can be manipulated in this way, and they can, but we still have an x upon an x. Notice this one, we don't have any x times x or x divided by x, which these do. So let's just go ahead and multiply it out. At this stage of the game, this is the FOIL method, but hopefully you know shortcuts by now. Since there's nothing in front, it would just be an x squared. These numbers get added together with x, so if I add 5 and negative 3, I get a 2, and like I said, there's an x that goes along with it. And then we multiply them together. 5 times negative 3 is negative 15. And usually we go the other way. This is what numbers multiply to be negative 15, add to be 2, and negative 3 times 5 is negative 15. Negative 3 plus 5 is 2. So it's nice just to check your work and make sure your math is tight and up to speed. Is that what we have? And yes, it is. Next question. All right, how would you rewrite f of x so it can be the power rule again? All right, so in this case, all of these look like they're algebra style questions. So once again, the trick would be you're not doing any x on x operations. So this one right here looks good, but we just want to confirm it turns into that. Notice these have x on x operation, x on x operation. This would be quotient rule. This would be product rule. So basically what we're going to do is I would just break it up into this form first. So it would be x to the 5th over x minus 2x cubed over x minus 8x squared over x. And once again, this is a good opportunity to practice our algebra manipulations. So notice going the other way, if I went the other way here, it would be common denominator. When you have a common denominator, you combine the tops. So at this stage, then I would just divide into each of these, and I get x to the 4th minus 2x squared minus 8x. Is that what we have? X to the 4th minus 2x squared minus 8x, and it is. See if the next one's any different. Product rule. Okay, so each one of these is going to be a little bit different with their manipulation, so it's just a practice of our algebra skills. So for this one, we want product rule. And it looks like all the rest are kind of focusing on what kind of rule do you want. Product rule. So this would be a quotient rule. Quotient, we're dividing an x function by an x function. So product rule means change it to multiply, which is easier. The more you do these, the more you'll figure out which ones are easier or not. A couple different ways you can manipulate this, but basically it looks like that x on the bottom is going to have a negative exponent to throw it in top. So I would say it would be like 1/3. I'd pull the 3 out front. The x moves to the top, so that makes it x to the negative 1, and we still have our sine function on top, sine x. So something like this. All right, so x on x function, x. So already you can kind of rule these out. we want a product rule, so it's an x on x function. Notice we have x divided by x. That's its quotient rule. So these are product rules right here, and it looks like just the 1/3, they moved it in front. Usually our coefficients would go in front, but that's fine. So there it is there. And last one, using the power rule. Power rule, we would just like we did on the first one, multiply it out that way. So this way, no x on x functions. And we have x on x functions, so it's probably this one right here. Multiply them out, add them together, and yes, so it would be something like that. All right. And stop. Where's my stop?